Relative relief maps show how much elevation changes in an area. They use lines and shading to represent hills, valleys, and other landforms. Unlike topographic maps with precise elevations, relative relief maps focus on showing the general shape of the land. Imagine looking at a three-dimensional model of a landscape. A relative relief map captures that visual essence in a two-dimensional format. These maps are valuable for understanding the overall topography of a region. They highlight areas of steep slopes versus gentle slopes. This information is useful for various purposes, from planning hiking routes to understanding water drainage patterns. The accuracy is crucial when creating relative relief maps. Inaccurate representations can mislead users about the true nature of the terrain. For example, an inaccurately drawn slope might appear steeper or gentler than it actually is. This could have consequences for activities like hiking, construction, or even military planning. To ensure accuracy, it's essential to start with reliable data sources like topographic maps. These maps provide detailed elevation information that serves as the foundation for your relative relief map. Additionally, using appropriate tools and techniques, as discussed in the next section, is crucial for translating that data into a visually accurate representation. Creating an accurate relative relief map requires a few essential tools: a topographic map of your area of interest, a ruler, pencils of varying hardness, and an eraser. The topographic map provides the elevation data, while the ruler aids in maintaining scale and proportion. Pencils allow you to control the darkness of shading to represent different elevations. Begin by lightly sketching the outline of your chosen area from the topographic map. Next, identify the highest and lowest points to establish the elevation range. Using your pencils, start shading areas of higher elevation with darker tones, gradually lightening the shade for lower elevations. Contour lines connecting points of equal elevation can be added to further enhance the representation of the terrain. Common errors include inconsistent shading, inaccurate representation of slopes, and neglecting to maintain a consistent scale. To avoid these pitfalls, practice regularly, focus on smooth transitions between shading, and double-check your work against the original topographic map. Mastering the art of creating accurate relative relief maps offers several benefits. These maps provide a clear and concise way to visualize the topography of a region. This understanding is essential in many fields, including geography, geology, environmental science, and urban planning. For instance, geographers use these maps to study landforms and their impact on human activities. Geologists use them to understand the underlying geological structures of an area. Environmental scientists rely on them to analyze erosion patterns and water drainage systems. In urban planning, accurate relief maps assist in infrastructure development and hazard mitigation. Overall, the ability to create and interpret relative relief maps is a valuable skill. It provides a powerful tool for understanding the complexities of our physical world and making informed decisions about our interaction with the environment.